How firefighting planes really battle wildfires. A massive aircraft tears through thick smoke, flying so low it looks like it might clip the treetops. Seconds later, thousands of gallons of red liquid slam into the ground below. Most people think that moment means a fire is being put out, but that's not what's really happening. Aerial firefighting planes aren't there to defeat wildfires head-on. They're there to slow something that in many cases can't be stopped at all. Every drop is a calculated move in a much larger battle, one where pilots fly into heat, turbulence, and near-zero visibility, knowing a single mistake could cost lives. These planes operate closer to danger than almost any other civilian aircraft in the sky, and yet, their role is widely misunderstood. What looks like a dramatic act of fire suppression is actually a race against time. The goal isn't to kill the flames, but to weaken them just enough for crews on the ground to move in. And the way these pilots pull it off, flying impossibly low, releasing massive loads in seconds and escaping the chaos, is far more intense than most people realize. Because once you understand what these planes are really doing up there, you start to see wildfire firefighting in a completely different way. Most people assume these planes are designed to wipe fires out in one dramatic drop. The reality is far less cinematic and far more strategic. Wildfires are simply too large, too hot, and too fast-moving to be extinguished from the air. Even dumping thousands of gallons of liquid directly onto flames barely slows them for more than a few moments. Instead, pilots aim somewhere else entirely. They drop fire retardant ahead of the blaze, laying down long curved lines around its edges. This creates what firefighters call a fire line, a treated strip of vegetation that's harder to ignite and slower to burn. When the flames reach it, they lose momentum. That pauses everything. It gives ground crews a chance to move in, dig fire breaks, and contain the spread before it jumps again. And that red liquid everyone recognizes isn't just water. It's a thick chemical mixture designed to stick to trees, brush, and grass instead of evaporating in seconds. The color isn't for show, either. It helps pilots see exactly where previous drops landed so they don't waste a single run. Still, this approach hasn't been without controversy. Environmental groups have raised concerns about runoff and long-term impact, sparking ongoing debate about when and where it should be used. But regardless of the arguments on the ground, the real challenge happens in the air, because placing those drops accurately means flying straight into the most dangerous part of the fire zone. And that's where things get truly intense. To make those drops count, pilots have to take their aircraft where most planes are never meant to go. Air tankers routinely fly just 150 to 250 feet above the terrain, weaving through canyons, radial lines, and uneven forest canopies. At that altitude, there's no margin for error. One unexpected gust or misjudged climb can put the plane straight into the trees. The fire itself makes everything worse. Extreme heat rising from the flames creates violent turbulence that can suddenly lift the aircraft or shove it downward without warning. Thick smoke blots out landmarks, distorts depth perception, and can reduce visibility to almost nothing in seconds. Pilots often rely on memory and instinct as much as instruments, navigating terrain they can barely see. Over the years, there have been close calls and tragic losses that underline just how unforgiving this work is. It's one of the reasons aerial firefighting pilots are among the most highly trained in aviation. They're not just flying the plane, they're constantly predicting how the fire, the wind, and the terrain are about to change. And even after surviving the approach, the most dangerous moment is still ahead, because the instant that payload leaves the aircraft, the physics of flight suddenly turn against them. When the drop happens, everything changes in a split second. These aircraft are carrying thousands of pounds of liquid, and releasing it all at once causes a violent shift in weight and balance. The center of gravity jumps forward, and if the pilot isn't ready, the nose can snap upward unexpectedly. That upward pitch is deadly at low altitude. Too much lift, too little airspeed, and the plane can stall with barely any room to recover. To prevent that, pilots are trained to do something that feels completely wrong. They push the nose down immediately after the release, sending the aircraft toward the ground for a brief moment before powering away. There's no time to think it through. The reaction has to be instant, precise, and automatic. It's drilled into muscle memory through countless training runs because hesitation can be fatal. All of this happens while the plane is still flying through smoke, turbulence, and extreme heat. But surviving the drop is only half the job. The faster a plane can reload and return, the more effective it becomes. And the methods used to refill these aircraft are just as intense as the drops themselves. Once the plane clears the fire zone, the clock starts ticking. Every minute spent refilling is a minute the fire keeps spreading. For most air tankers, that means racing back to an airbase where crews are already waiting. High-pressure hoses are connected, tanks are refilled in minutes, and the aircraft is back in the air almost as fast as it landed. But some planes don't need to stop at all. Amphibious aircraft known as super scoopers use nearby lakes or rivers as moving refueling stations. They skim across the surface at nearly 100 miles per hour, lowering scooping probes as the plane stays on step. In about 12 seconds, the tanks are full again without ever shutting down the engines. It looks effortless, but it's anything but. Pilots have to judge water depth, surface conditions, and obstacles in seconds. A miscalculation can damage the aircraft or worse. Still, when conditions are right, these planes can make repeated drops faster than any other system available. And yet, even with speed and precision, no aircraft operates alone over a wildfire. Above the smoke and chaos, an entire command system is quietly controlling every move. Above the fire, there's a layer of airspace most people never notice. This is where coordination happens, and without it, aerial firefighting would turn chaotic fast. With multiple aircraft flying low, often in heavy smoke, strict organization is the only thing keeping them from colliding or dropping in the wrong place. Smaller lead planes are usually the first to enter the area. They fly the intended path at low altitude, reading the wind, terrain, and smoke conditions in real time. Once they're confident, they mark the exact drop zone with short bursts of white smoke. That signal tells the larger air tankers precisely where to fly and when to release, removing guesswork in an already dangerous environment. Higher above the scene is the Air Attack Group Supervisor. This pilot acts as the eyes in the sky, managing every aircraft involved while staying in constant contact with ground commanders. They decide which planes go where, how drops should be spaced, and when conditions are too dangerous to continue. If the fire shifts suddenly, they're the ones routing aircraft in seconds. It's a carefully controlled system, but it has to stay flexible. Winds change, fires jump lines, and visibility can disappear without warning. And depending on how intense the situation becomes, different aircraft are brought in for very specific roles. Not all firefighting planes are built for the same job. Each one is chosen based on terrain, fire behavior, and how quickly crews need support. When a fire explodes in size, very large air tankers are sometimes called in. These massive aircraft can carry more than 8,000 gallons in a single run, laying down long, continuous lines that can slow a fire's advance in one pass. They're powerful but expensive, and not every airfield can handle them. Large air tankers are the real workhorses of wildfire response. Planes like the C-130 or RJ-85 strike a balance between payload and maneuverability, making repeated drops where precision matters most. They're often the backbone of sustained firefighting efforts. Then there are the water scoopers near lakes or coastal areas. These planes can dominate a fire by cycling drop after drop with incredible speed. Their ability to refill without landing makes them invaluable when conditions are right. On the other end of the spectrum are single-engine air tankers. Smaller and more agile, they're used for quick targeted drops, especially in remote areas where larger planes can't safely operate. Each aircraft plays a role, but none of them can win the fight alone, because even with all this technology in the sky, wildfires are becoming faster, hotter, and more unpredictable, and that raises a much bigger question about what comes next. For all the power and precision in the air, these planes are only buying time. Once the retardant is down and the flames slow, it's the crews on the ground who finish the job, cutting fire breaks, clearing fuel, and holding the line as conditions shift. Without that follow-up, even the most perfectly placed drop doesn't mean much. That reality is becoming harder to ignore as wildfire seasons grow longer and more intense. Hotter temperatures, drier landscapes, and unpredictable winds are pushing firefighting systems to their limits. Some experts have started questioning whether aircraft alone can keep up with fires that now spread faster than response times allow. Others argue that aerial support is more critical than ever. Even if it's not a permanent solution, what's clear is that these pilots aren't just flying planes. They're gambling against physics, weather, and time every single run. And the next time you see a firefighting aircraft skimming the treetops and releasing its load, you'll know it's not about putting out the fire. It's about slowing the inevitable just long enough for people on the ground to stand a chance. And that's the truth about aerial firefighting. Part skill, part science, and part sheer bravery. These planes don't chase glory, they chase precision. Every drop, every maneuver, and every second in the smoke-filled sky is calculated to give ground crews a fighting chance against flames that can move faster than anyone can run. It's a system built on trust. Pilots trust the physics in their training. Crews on the ground trust the drops to slow the fire. And everyone relies on split-second coordination in conditions most people could never imagine. The planes are powerful, yes, but they are only half the story. The real battle is fought in the tension between speed, danger, and control, and in the resilience of the people willing to risk it all. So, next time a wildfire fills the sky with smoke and red streaks appear from above, remember what looks like a single heroic act is actually the product of intense planning, precision flying, and teamwork at its most extreme. The fire might rage, but for a few crucial moments, these planes and the people behind them are the only things standing in its way. If you're fascinated by planes, pilots, and everything that happens above the clouds, don't miss out. Hit that subscribe button and join us at Aviation Insights. We dive deep into the secrets, the risks, and the incredible stories of aviation you won't hear anywhere else. Turn on notifications so you never miss a flight into the world of aviation like this.